All right, CNT140, we are on Chapter 7. We just got done looking at our flammability ratings on copper and fiber cable. So we're now looking at a section on designing your pathways and spaces. There's industry standards that cover designing pathways and spaces. Yeah, our TIA 569 standard has all kinds of information about pathways and spaces. So this is kind of our go-to for anything in this category. So they remind us we need to provide adequate space and design for our cabling system. This design is not the sole responsibility of the cabling designer, contractor, installer. This also has to be a cooperative effort with anybody else involved. Architects if it's something new, engineers if it's something new, maybe any staff that's on hand, mechanical, plumbing, etc. Because various things might need to be done in the closet, like new electrical circuits put into the closet and that sort of thing. So it actually is a cooperative effort. It is not a one person show, if you will. There needs to be a familiarity of the cabling and industry standards, which is one of the reasons I keep having you guys look up various things from the standards. You at least know where to go to look things up later. You can't possibly remember everything in the standard, but you'll at least know where to go and look up, and at least understand the kinds of things they're telling you. Proper installation depends on your proper design. You got to have a good design for the plan to, potentially work, if you will. When cables are out in the building, cables need to be kept dry and in moderate temperatures. Cannot be too hot, cannot be wet. And they remind us about ceiling, above the ceiling in buildings can be really hot. So the cabling needs to be installed where you don't have those issues, where it's not too hot above the ceiling. Any support for the cabling, supports need to be in place, but any supports for the cabling should be wide enough to support it so it's not buckling or bending, and space close enough that supports space close enough that the cabling is not sagging or the weight of the cabling is pulling it down. So as we're dealing with that, we're thinking about this kind of thing here, making sure it's wide enough to support all the cabling. Here's a better example. We have room to spread out the cabling if we need to, and strong enough. There is actually, we'll look at this when we pick out our trays for the bid spec. There is actually tables that'll tell you how much weight a particular tray will hold, and or if I'm looking at how many cables I'm putting in a tray, this chart will let you know how many it can actually support before it becomes full or would start buckling or damaging under the weight of the cabling. So there's resources to help figure out what do I need to make this work. And those are the things we'll be looking up too. The performance of our system is really dependent on the installation, having a good installation too. So all of our components, all the components of the structured cabling have been designed, tested to meet the 568 standard. So as I'm installing them, I need to use the quality components that are rated thusly and install them properly so they will actually perform at that rated level. There is horizontal pathways we have to worry about. There's backbone pathways we have to worry about. And these can be vertical or horizontal depending on the layout of our system. And any kind of interbuilding backbone needs to have some kind of pathway. This could be a conduit or something between those two buildings. So in a building like this, we're talking about backbone spaces here, usually vertical conduits between the closets. And horizontal pathways here, typically trays, cable trays like we have in our lab room, or J-hooks like we'll be looking at adding for our bid spec project to support the smaller bundles of cabling. So again, vertical conduits here for backbone between closets, and cable trays and J-hooks kind of thing for supporting cabling in the horizontal space. If you do have any kind of inter-building connection, let's say this is a campus, like a college campus type thing where you have multiple buildings, there needs to be conduits or systems in place to move the cable or have the cable go from building to building. Pathways include cable trays above your head, conduits between floors. Okay, I'm putting some pictures in here to connect dots for you. These can also be spaces under a floor. You might have a data center where the floor itself, you can lift the tiles out and lay the cabling underneath. Here's a giant suction cup to lift the floor tiles out. And you literally lay the cabling on the floor, the concrete floor, if you will. That's where it says about cabling must be cool and dry. And again, any kind of trays or things that I'm putting in, there's usually manufacturer data to let you know how many cables or how much weight that particular tray or support can hold. And again, we're talking cable trays, we're talking J-hooks. Here's a couple different sizes J-hooks over here, and these can get anchored to the I-beams or steel structures up above the ceiling. We're also talking interduct to support fiber optic cabling. Interduct is a tube. It kind of reminds you of like swimming pool hose, if you will. A tube that you install that allows you to pull the fiber optic through with low resistance. And after it's pulled in there, it now has a protective tube around it for other cablings or other things that are in the tray. And we're also talking raceway coming down the wall to outlet boxes. They remind us about in the ceiling. Okay, here is actually a suspended ceiling. Some people call it a drop ceiling, but suspended ceiling. This is in many offices, many rooms, many buildings, many schools, that kind of thing. You lift the tiles out of the way, and if you get above there, there's a grid work up there that supports all those tiles. Well, what they're saying is you can't lay cabling on this grid work or on top of those tiles. In some cases, the cabling is heavy enough that it will break through the tiles. In other instances, I only have a couple cables. Well, those couple cables up there might be in the way of something else. So somebody goes up to work up there and, kind of shoves your cables out of the way, they could get damaged. So for a couple reasons, we don't lay them on the ceiling tiles. There is even a National Electrical Code that says, hey, you can't even anchor them to, if I look back in this picture, there's wires here that hold up the ceiling grid. You're not supposed to anchor to those either. You can, however, though, have your own cables come down from the ceiling structure to anchor your cabling to. That can be done. They also remind us about grounding and bonding. All of our trays, usually our trays are of some sort of metal. As the trays join together, they should be bound together. There should be an electrical connection, if you will, between those trays. The idea being, if any kind of electrical short, power or whatever hits this tray, it could energize that whole tray structure, and you don't want that to have that happen. So each tray is linked together, and then when it gets back to the closet, to the equipment rack, that is then anchored to a ground bus or ground bar that connects it to building ground. That way any stray electricity that would hit a tray or rack or whatever can get safely pulled away to the building ground, and not you, the person that would receive the electricity. You're getting shocked. There is a standard and guidelines for doing all the grounding and bonding for trays and racks and so forth. In the work area, we're talking this area. Okay, so the work area, this part of our structure, this part of our structure. We are going to have outlets for the users. It could be in outlet boxes like this or like this. Could even be worked into the wall like so. Could even be in the bottom of a cubicle, through the frame of the cubicle. That, the work area can be divided up, modular framing, that sort of thing. They're saying for the work area, there should be, 100 square feet for the user. And there should be at least, they talk about 2 outlets there. Old school day was 1 data outlet and 1 voice outlet. Nowadays, most are data because you run a voice over IP across, but they're saying, hey, there should be outlets there to be able to plug these pieces of equipment in. And they're saying it should be close to power as well, so you can plug a computer or any other device in. Your 568 standard has requirements or standards for the work area. If I dig into that, this talks about the work area and what should be there. And I believe here as well, if we go to the 568, it talks about having minimum of 2 outlets provided for each work area. And in an environment where you have lots of cubicles, I'll go back here real quickly, this type of structure, these things might get moved around a lot. So there actually is a standard MUTO, multi-user telecommunication outlet assembly, that allows for cabling areas like cubicles a little bit differently. What it amounts to is you're going to put an outlet jack above the ceiling and then use a long patch cable down to the work area. That way you're not moving that solid core cabling around in the cubicles all the time and have them break. So in our standard, there is a MUTOA option here for cabling up that type of structure. And they even talk about how you do that. And you basically have a, instead of your data outlet next to the computer at the desk, the data outlet would be above the ceiling, because that's your solid core wire then, solid conductor wire. And then you can use a long patch cable to come down to the user in the work area. And in the standard, they have guidelines on if the length of the horizontal run is this, your patch cable can be this long. And it basically, the longer you make that patch cable, the shorter the horizontal cable run has to be to make sure the system works, the signal works. But that allows for wiring up a cubicle type environment where things move around a lot. And again, remind us about some things in the telecommunication room. There should be at least one on each floor. If you have a multi-floor building, there should be one on each floor to service that floor. It's going to house your patch panels and your switches, those types of things. That might be it. It should be located to the center of that area as best as possible. That way you're limiting distances. And it should not be shared with really any other facilities. There shouldn't be lots of electrical panels and other things in there, pumps and whatever. It should be kind of a dedicated space to this as best as possible. So again, we're talking about this area, interconnection, horizontal coming into the patch panel here, switches here to connect into, and then backbone cabling to other closets. So this type of arrangement, or this type of closet, this type of closet, and this type of space. The interconnection between the horizontal and backbone. That's the area we're talking about. Again, one telecom room per floor, unless the area gets too large, basically cable distance gets too long, then you might actually need two closets on a floor, maybe one on each end if you will. The space in the telecommunication room should be large enough for the equipment that is needed to serve that area. The closet should have conditioned and uninterruptible power, as we said before, separate data ground. Lighting and other electrical equipment should be run off of the normal building power, and then a dedicated building power to the equipment in your closet. Again, if I look at my standards, 568 standard has stuff about telecommunications rooms, what's required, how things should be done. 569 also has requirements for these telecommunications rooms. They call them distributor rooms. There's even guidelines on how that room should be laid out so that you actually have room to get equipment in. Door needs to be wide enough to get equipment in and out of the room. And then where your racks are, so you have room to get around them on each side to put equipment in, take equipment out, cable up, etc. And then they talk about having cable trays and supports in the closet to get the cabling over to the rack and so forth. In the 569 standard, here is some of the requirements for the closet. These talk about those things we said about floor space and minimum of one per floor and so forth. Dedicated outlet, electrical outlet for temperature and humidity in the room controlled. Okay, all those things, and even down here is the size, the dimensions of the closet. If you're serving an area, X number of users, my closet space should be about yay big. And that's giving you kind of the rule of thumb so you know you have enough room for all your equipment. The main equipment room in the building, this is the one where you probably have your entrance facilities, servers, those kind of things. These also have requirements as well. And they're going to be similar to what we just got done looking at. These need to be sized and large enough, accessibility for equipment, conditioned power, lighting, adequate air conditioning, etc., etc. And again, 568 standard has guidelines. 568 standard, this is the requirements for the room or recommendations for the room. 569 has the same set of standards, layout of the room, as well as what requirements for power, air conditioning, etc. in that equipment room. All right. When we come back, we'll continue on.